So good morning, everybody. I will continue today on this lecture related to chapter 1. And I was talking last week on Thursday about some data that I got here about the pandemic. And I started by showing some data from the pandemic that look like a database, like I discussed in the class. But just before we continue here, I just want to show you that on Canvas today, we are going to have the Canvas, like I said, it's pretty much just focusing on you doing quizzes and the exams, and all the quizzes and exams can be done in any place where you are. What I realized that taking together all quizzes points, that's 20 points, that's a lot of points throughout the semester. Really few students in this last semester got A's, right? So considering the 20 points altogether. I think that's because people don't concentrate when they're taking quizzes, they do in whatever place. Try to go to a quiet place, to the library somewhere where you can concentrate and you can have your notes with you. It's all open book and everything. So the quiz is going to be 2 points, 1 point, 2 questions. And on Canvas, it's really simple. You just have this overall information about our course and the assignments here. You're going to be able to do the quiz today, start at 12:25 p.m. as soon as the class finishes today. But it's going to be open until tomorrow, 8 p.m. And you're going to be able to see the correct answers in the following day on the 27th at 8 a.m. Okay, so that's going to be the same system. Opens at the end of the class on the quiz day, 12:25 p.m. Closes 8 p.m. the next day. And then the following day, 8 a.m., it shows the correct answers. It's going to be about the chapter 1, this overall, and also about topics that we are discussing in class. I have a question bank about this topic, and Canvas will randomly select 2 questions. So the questions will be different for all of you. And also the options that will appear, they will be randomized also in the categories, the options A, B, C, and D. Okay. After you open the quiz, it's open until tomorrow 8 p.m. But after you open the quiz, you have 5 minutes to finish it. Some people with disability that send me that ask the Disability Resource Center to send the accommodation letter that informs whether I have to give more time for them to take quizzes and exams. I already put it there on Canvas. So for those people that send me the accommodation letters, they will have more time than 5 minutes according to the accommodation letter. If you have a disability and you have you would like more time, you have to ask it for the disability resources, right? And that proportionally, the additional minutes that you're going to have on quizzes will be also added to exams and the final exam. So and in the quizzes, I always say to read the instructions on the syllabus. So everything that you should know how the quizzes and exams are organized are in the syllabus here. And as you know, this is the course website where you can download all the lectures and everything and all the material. And then in the syllabus here on page 4, that's where I explain in detail how the quizzes and exams and final exam, they are organized. Why am I talking about this today? Because today is going to be the first quiz that we have, right? Yesterday was the last day for adding and dropping classes. And I thought that more people were going to drop classes, but actually the enrollment increased to around 80 students from 72. So, but today is going to be the first quiz, and the dates for all the quizzes and the exams throughout the semester will not change. So you should expect to have these quizzes open exactly at 12:25 p.m. in those dates here, okay? And exams, they open from 8 a.m. to 8 p.m. on the exam day. Exams are open for a shorter period of time than quizzes. Cool? The quizzes and exams, the question banks, the style of the questions, they all come from the same source. They all come from the same question banks, right? So if you are doing the quizzes, you are actually training for the style of exams. Cool? Any question? All good? We are still here looking at the lecture about chapter 1. And this extra article here about cohort definitions by Dudley Poston, who is the same author of the textbook, is just this short article that he wrote for a magazine, and he kind of details, gives some numbers. And I just got this table here, and I added, in previous semesters into this lecture. So if you want to just read this article, it's just interesting for you to have this extra reading. That's it. It's really short. Only these 2 pages here, okay? And so we will continue on the slides here. I was talking to you about the percentage of people fully vaccinated, how it has been increasing over time, and actually Brazil even passed the US by the end of this last year, or early this year. And I finished on this slide here about the concept of flattening the curve. When we have the number of cases, the curve of cases that oscillates a lot, because you have so many cases like this one here that oscillates a lot here in the US, the red line. When we are talking about flattening the curve, that concept that we hear a lot in public health, what we are trying to do is to make the log of these cases have a more flattened appearance in this graph. So in this case, it's pretty much, why do we take the log? The log pretty much takes all these numbers of cases that are really strong and high and put them a little closer to the other ones. And then the variation here, you see less variation in the graph. But it increased a lot from a time before the pandemic until now. And so now the goal is to flatten this curve so the cases don't increase much more. But this was the graph that I was starting to talk in the last class. And that's just positive test rate. So it's pretty much how many people are being tested positive throughout the pandemic for COVID-19. And we see that just in these last few weeks, because of the Omicron variant, the number of cases have been increasing a lot. But as we saw, the number of deaths is not increasing so much proportionally of how it was in previous waves, exactly related to the increase in vaccination rates in the country, right? But still, the level of deaths in the US is still high. It's not so high as it was back in 2020, by the end of 2020 and beginning of 2021. If you think about the level of cases that we have now, but that exactly related to or associated to vaccinations. So in order to have a picture of what's going on in the country about pandemic, we have to go to all these different data sources. And that's when we are talking about John Grant, the father of demography, that he was really skeptical about data and so on, we have to go to data sources that are reliable, and we have to get all different pieces of information when we analyze such an important topic. And here is just the number of patients in hospitals, just to emphasize that, yeah, the vaccination rates, because a lot of people are vaccinating now, so they might get sick, but not as severe as if they were not vaccinated, but still a lot of people are still entering the hospitals because of COVID-19 infection. And here I'm showing just the data for the US, and number of patients in intensive care units is still high, right? So the number here in recent weeks is still as high as it was in mid-2021, not so high as how it was at the beginning of 2021, but it's a really public health concern. And in this case here, I'm getting information from the New York Times. I just got this data from the same link that's at the bottom of the slide, and I put one graph over the other. Here we have number of cases by day and number of deaths by day. And what we have been seeing in the US or everywhere in the world is that once you reach a specific peak, once you see some increase in the cases of people infected by coronavirus, after a few weeks, you see increases in the number of deaths. So that's why I put this dash blue lines here, exactly when you see increases in cases. A few weeks later, I mean, the average was usually like around 2 weeks, you see increases in deaths. The same thing you see here as well, the same thing here. And what you have been seeing about the Omicron variant is that the number of deaths, they start to happen much faster than what it was with the previous variants, right? And all this data here, I got them from these data sources back in January 17th, the day before this course started, the semester started. Here is the average daily cases per 100,000 people in the past week. This is data that I got back in October 2020 when I was teaching the same class, and we saw that the eastern portion of the US was the one that was experiencing more daily cases. And then I got this by the end of that same semester, November 2020, and you see a shift of cases going to the western portion of the country, but also, of course, really concentrated in the middle of the country. And more like in last year, in August last year, and this is usually at the beginning of the academic semester, when I go back to these websites to update these graphs and maps to show to students. And then you see actually in more southern states, an increase in number of cases. And now pretty much you have really high levels of cases of coronavirus and related to that same graph that I showed before with this huge increase in cases due to the Omicron variant, okay? And usually New York Times, I mean, they do a great job. Sometimes they change the scale of these graphs over times and maps. But for these specific maps here, the scale is the same. So we can have an idea, darker it is, darker the number of cases, already take into account the population in the denominator. So these are rates, okay? Current hospitalizations per 100,000 people back in August 2021, also related to the other map that we saw by cases in the southern states. You see higher cases of hospitalizations. And then now you see a decline comparing to previous, to that previous map, but it's still a large number of areas here you see still high levels of hospitalization per 100,000 people. Specifically in Texas, also from the New York Times. And per state, the New York Times gives data for cases, deaths, hospitalizations, and tests by day. And the graph here, it's really similar to what we saw for the overall US. Number of cases increase right after you see deaths, cases, deaths, cases, deaths, and now cases and deaths start to increase again, right? But proportionally, if we were not vaccinated, of course, the number of deaths would have been much higher proportionally. But because we are vaccinated, a great portion of the population is vaccinated, the case of deaths decline a lot. But if it was not the case of vaccines, these numbers would have been much higher. And proportionally, that would have been scary, right? Because this number here is related to this. This number here, this curve would go much higher, okay? All this data is public available. All this data are examples of public health data, and in this specific component of mortality and morbidity related to demography as well, right? And this was the case. This, I think, is data only for the first year of the pandemic that the New York Times reported. And here I just look at colleges in Texas and the top colleges with more cases of coronavirus. They also have data for nursing homes, prisons, and other places. And just to annoy the students, I see that at least in this case here, you guys beat UT Austin, right? So at least one way. Just a joke, a bad joke. So I mentioned at the beginning of the slides last week that I was going to explain different ways that we can do studies in demography, right? So usually you have two kinds of, you can subdivide demography in two kinds of studies: formal demography and social demography. Here we are doing social demography in this class because we are getting information about trends and levels of fertility, mortality, and migration and linking them into other aspects of our societies. We are trying to understand if mortality, fertility, and migration vary by age, vary by sex, vary by marital status, vary by socioeconomic status, vary by race, ethnicity, vary by different political aspects, ideological aspects, right? Vaccination, there are already data showing that in counties that had the highest support for the former president, the levels of vaccination are lower than in other counties in the US. So all these different aspects of how these demographic indicators are associated with other aspects of our lives, that's social demography. Formal demography, it's usually when we are trying to understand what other demographic factors are influencing one specific demographic factor that you are analyzing. So it's peer, let's say that's kind of peer demography, right? And usually formal demography, usually these studies are really, go really in depth in mathematical equations and so on. But just to give you some examples. Formal demography then, and I discussed this last week, what are independent variables and dependent variables. Both the variable, that's the consequence, that's the one that we are trying to understand variations, that's the dependent variable, and the variable that we think is the cause of changes on this one, they both are demographic variables. So the independent variable, the cause, and the dependent variable, the consequence of that specific one, the main variables that we are analyzing are demographic variables. Examples. Age composition. If we have a population that we have a higher proportion of people between 15 and 49 years of age, these are reproductive ages, right? Where you have the highest chances of people having kids, or let's say between 20 and 35. If you have a specific population with a high proportion of people between 20 and 35, these people are more likely to have children than societies that have a higher proportion of people in older or younger ages. So in this case, this population with higher proportion of people in reproductive ages will tend to have a positive effect on birth rates. We tend to see an increase on birth rates. So for example, European countries that have been, we have seen drops in fertility in those countries for several decades already. And now we have a really aging population, a lot of people with older ages, with at least 60 years of age. These people, chances of having children is much lower. So the birth rates are decreasing in those countries. So in this case, I'm talking about all demography, right? Age composition and birth rate. And in this example of Europe, I just said, in the past, for different reasons, they had a decline in fertility, right? So women started to invest in education, invest in having jobs before they form a family, before they have children. So there is a postponement in the age in which they have children. When they postpone that for several reasons, because the society doesn't have free or affordable childcare, and then they have to decide between having children and invest in their career. So in that case, they will postpone the age in which they have children. Birth rate drops. In the next few years, what you're going to see is this process of aging population, more people in labor ages and older ages, and proportionally, fewer people in younger ages. So in that case, birth rate is affecting age composition, right? So there is a reverse causality there. Age composition affects birth rate, and birth rate also affects age composition. Sex composition of immigrants to a city affects the sex ratio of the total population of the city. You're going to see throughout the semester, for example, some Middle Eastern countries that have a lot of migration, and in that case, it's international migration of male workers to work in their oil industry. And because of that, the overall population have more men than women, right? So in that case, is an example of the sex composition of international migrants. And I explained the difference. This term here, in migrants, is related to internal migrants, people moving from one city to the other. Immigrants are those moving from one country to the other. So in these Middle Eastern countries, they receive a lot of immigrants from other countries, and a lot of them, or most of them, are men. And that affects the composition of that society where they are moving to, that country that they are moving to. Now you have more men than women. When you divide men by women in a society, multiply it by 100, what do you have? The sex ratio. Our sex ratio is an indicator. It's the number of men divided by the number of women. And to report in percentage terms, you multiply by 100. You can also have the sex ratio at birth that we talked before. Sex ratio at birth, you get the number of boys born in a specific country in a specific year divided by the number of girls born in that society in that specific year. In this example here, we're talking the overall sex ratio. If we have more men entering a society to work in that specific country, you're going to have an increase in the sex ratio in that specific country. And then you have social demography. And here in this two slides, this one and the next one, we just invert the order of the independent and dependent variables. So in this case here, the independent variable is a non-demographic variable, and the dependent variable is a demographic variable. In this case, we're just saying the focus of our analysis is to link demography into another aspect of our society, into another social science, into another discipline. Because our interest is to see how aspects that are non-demographic influence demographic variables. And that's the subgroup here of social demography. So for example, we should expect that social class, people that have higher socioeconomic status, they have more resources to health services, they have better access to food and to habitation and everything, and that makes them live longer. They have more access to medication, they can afford them, and so on. So it's an example of how an aspect of our society, social class, socioeconomic status, can influence a demographic variable, in this case, death rate in this example. So that's a sociological variable influencing a demographic variable. Attitude about motherhood, so more related to social psychology. How women in a specific society see themselves. Do they are really expected to be mothers throughout their lives or not? Or that culturally speaking is not such a strong pressure that they receive from their society. But that attitude about motherhood, how that's seen by the society as a whole and by the women themselves, will affect the number of children that they decide to have. And whenever I'm talking about fertility, in this case, it's really clear here, motherhood. But when we're talking about fertility, we usually focus the analysis on the number of children that women have. It's just because that has been the standard in demography, and we're going to discuss about that in the chapter about fertility. So we have more historical data about fertility collected from women, exactly because also women, they better know how many children they had throughout their lives and their ages and so on. And in some countries, men just don't know that information, right? So, but a lot of studies have been emphasized that's also important to understand male fertility. But whenever we talk about traditional data about fertility, we are getting that data from women. Geography, how geography can affect demography. Annual rainfall can affect population density. So annual rainfall changes in climate in specific areas might make people move out from those areas, right? One really clear example was Hurricane Katrina, for example, in New Orleans. When you had the Hurricane Katrina, a lot of people moved out from the city. A lot of them moved back in, but some did not move back in. There is a professor, I don't know if I already cited him here last week, Matt Hauer from Florida State University. His work was recently cited by the White House, and he analyzed exactly that, climate change in specific areas, more in the coast, how that is affecting out migration from those areas. And that changes population density, the number of people per area, per specific unit of the area, that can be square feet and so on. Another one, economic opportunity, which is an economic variable. If we have a country, an area that's growing, has a lot of job opportunities, will increase, will attract more migrants. So more people will migrate to those areas, right? And that's within the US, that's the case of Texas, for example, that has been experiencing economic development and growth in jobs in these last decades. Of course, now the pandemic shift a lot of change, a lot of these aspects, but overall, Texas is one example of a state in the US that's attracting a lot of internal migrants and international migrants, right? So that's an economic aspect affecting migration, but you could also say, oh, but also migration affects the earnings in that population. So higher earnings here attract more people, but once more people arrive, they might be competing for more jobs. There is a negative effect on earnings, right? So there is also reverse causality. Whenever you have reverse causality, the analysis, the empirical analysis is more difficult, right? Because then you have to implement some more complex models to understand the direction of that arrow. This case here is also social demography, but now we are focusing on how demography affects non-demographic variables. So age composition, usually countries that have higher proportion of younger people, usually younger people tend to be more leftist, or using the American term, more liberal, and then they tend to vote into more leftist candidates, right? Migration, whenever you have migration from one place to the other, that might change the composition of that society. and create some social change, both in cultural aspects, or it can actually change because it changes voting behavior. It can also change how the society is organized in terms of neighborhoods where people live. It can change in terms of job availability, which jobs are available. It can change about which kind of food is available for the population, because migrants bring with them their diet habits, their nutrition habits, and then that food starts to be available to everybody. So everything changes. Birth rate. If you have an increase in birth rate in a specific country, we will need more services, more for childcare. So need for infant and child good services in that specific location. So that's an example of how demography influences public health. One other example, we can have an increase in fertility, and also people now going more to school, an increase with people getting college degree, that it's overall good for the country, right? But let's just see here. We have an increase in fertility in a specific time point. The specific time point, you have a lot of people being born that were not done in previous years. And those people, throughout their education years, they all access college in a greater rate than previous generations. And when these guys here enter the labor market, they will have better education overall than previous generations. So overall, they will see an increase in their earnings. But now they have more people because of increasing fertility back then, and more education, and they will compete more in the labor market. That can have a negative effect. Did this ever happen somewhere? Here in the US, there was an unexpected increase in fertility right after World War II. So the country was experiencing a lot of economic development, a lot of jobs being created, and then people start to have more children. There was the baby boom, right after World War II. And when these children, they go to school, because the education system gets more affordable and public schools to everybody and so on, or to a higher proportion of people, not to everybody, but to a higher proportion of people, they tend to have, the baby boom cohorts tend to have higher proportion of college-educated people than previous cohorts, than previous generations. When they enter the labor market, by the end of the 60s, beginning of the 70s, overall, they have better earnings because they have higher education attainment, but they'll be competing with other people. There are several studies dealing with that specific aspect. Using more recent data from Brazil, from 1970 to 2010, I kind of saw the same thing. You see, the fertility actually dropped throughout this period, but education increased a lot. And once education increased, these people start to have higher earnings. But now you start to see more competition of people in the labor market. You see a negative effect. So what you're saying pretty much there, that the age composition and education composition affect earnings. In that case, age composition, demography, education composition, let's say education, is affect earnings, an economic variable, right? In that case, more specifically, people who get college degrees in Brazil, they are more now, but when there are not as many jobs for them, so they don't compete as much. Who is getting worse are people only with high school diploma. The ones with high school diploma already have lower earnings than the ones with a college diploma, and they are more now in the country because people at least finish high school, and then they will see a negative effect on their earnings, both because they don't have a college degree and due to competition. So I took these previous studies about the baby boom. I talked to you before, right? About what is theory. Theory is of this knowledge that we have about a specific problem in our society that was tested for other countries in other times, and we try to use them to answer questions about other people. So I got the theories about the baby boom, previous studies that were done about the baby boom, and then I had an idea of what would have happened in Brazil now that education is improving. So I have hypotheses, preliminary answers to my questions based on those theories. And I applied that into Brazil and I got this information. People with college degree are increasing their earnings. People with high school degree have lower earnings, but their competition, the labor market is making their earnings go even lower. That's a problem for the society. We have to implement policies to increase more people with college degree. And that's my dissertation, right? I pretty much got a study that was done before, adapted it, had an idea of how the variables are related to each other, like in these examples here, had an idea of what the data would look like, analyzed Brazilian data, and got the findings. And I corroborated the same results that were founded here to the US about the baby boom, okay? So that's how we slowly progress in science, right? And I just talked here a lot about cohorts and generations. So cohort is a group of persons who have experienced a common event during a given time interval. And usually in demography, when we're talking about cohorts, we're talking about birth cohorts. And birth cohorts can be also called generations, such as I just used this term here in my previous examples. So people born around the same time, the baby boom cohort born right after World War II. Why do we care about birth cohorts? If you understand what distinctive opportunities and problems you have faced, you can find common ground with others in your generation and other generations. So in that case of the baby boom cohort, what we see is that more people are being born after World War II, and they are getting more education than previous generations. When they enter the labor market, they have more competition, their earnings decrease. So that's one example of how people from the same generation, from the same cohort, experience the same problems, the same challenges, right? Here in College Station, we see, for example, the university library, whenever you enter in a specific year, you have class of 2025, for example, right? And for people who entered here in 2021, those are people who will finish in 2025. And that's a way of the university to force you guys to graduate around the same time as everybody. So that's good for the indicators of the university, people graduating within 4 years. But it creates a bond, right? People that enter the university around the same time, they are facing the same challenges. Now the pandemic, that previous students did not face that. You have other challenges that you're facing right now. It could be even getting access to student loan and so on that other generations did not experience. So that bond that you guys create for being part of the same cohort within the university creates some experiences to you that are unique to you and different from other people, right? But usually demographers, when we are talking about cohorts, we are talking about birth cohorts, when people were born. And some examples of cohorts is exactly that short article that I mentioned to you by Dudley Poston. I just tried to summarize here a little bit. There is not like a consent of these terms for the most recent generations, but those are terms that you might hear whenever people are talking about demographic changes. The good warriors, or the greatest generation, born in the 1900s through 1920s. Lucky few, those are the ones in which you had low levels of fertility. Those that were born around 1929 and 1945. Why do you think there was like lower fertility around the time, around those years for the lucky few cohort? The Great Depression. So you see a lot of unemployment, earnings declining, so people have fewer children. And then right after that comes World War II. So all these challenges, lower fertility, but when these people that were born around these years enter the labor market, they are fewer, right? So they have more resources from the society to them. So that's why they are called lucky few. Their parents were not lucky, but they are later in life, right? Baby boomers, exactly those born after World War II, between 1946 and 1964. Generation X, or baby bust cohort, when you start to see again a decline in fertility from mid-60s to early 1980s. So I'm from 1977, I'm in that specific group. Millennials, those born from early 1980s to early 2000s, or also called new boomers or Generation Y. And Generation Z start in the early 2000s, right? And so this is just to create an idea that how the specific people born in the specific years, they experience the same aspects in terms of education, in terms of job opportunities for them later when they grow up. And the lucky few cohort is emphasized more by the author of the book because he is from the lucky few cohort. They were fewer compared to a much larger number of persons in the following cohort compared to the baby boom cohort that came afterwards. And the smaller size of the lucky few has enabled them to experience higher levels of employment and also a greater variety of social opportunities than members in the preceding or following cohorts, right? That's related to what I just said, no. And this table here, I got it exactly from that article that you can download in the course website. The birth cohorts, New Worlders, Hard Timers, Good Warriors, Lucky Few, Baby Boomers, Generation X, Millennials, Generation Z, the years of birth, the age range in 2020, none of them are living anymore from these ones, and older people until the younger people. Right? Number born in the US in total. So we see that still, because you have a higher population in more recent years, you tend to have more people from newer generations, but you see one different trend here. See, baby boomers increased from 44 million from the lucky few to 75 million baby boomers. And then it dropped by the next generation. And then it started to increase again and dropped again. But here, this increase is not because women are having as many children as we saw in these previous years. It's here is because you have more people overall. The population is bigger in the US between 1983 and 2001 compared to 1946 and 64. And those alive in 2019, and those numbers include immigrants. That's why here for Generation X, Millennials, and Generation Z, you have more people alive in 2019 than those born in the US, because here, born in the US, here, alive in 2019, including those that entered the US from other countries, right? A number born in the US per year, you see also the same trend that we saw for this column here, a huge increase. The baby boom cohort from 2.5 to 4 million declines and then starts to increase again, and more related to the number of the size of the population in more recent decades. Okay. This is a graph that summarizes 7 US birth cohorts by size. And then you see exactly that huge increase from the lucky few to the baby boomers. And in this graph, in this axis here, you have the year of birth. So the newer cohorts here, they're being born later on. They're more at the back of the graph. And here the number of people born in those years. But you see that from the lucky few, 41.3 born during the years of the lucky few cohort and 79 million during the years of the baby boom cohort, right? And that huge increase changes the population composition. Then at the short term, you have more kids. Later on, you have more people in labor ages. And the baby boom cohort now is reaching retirement ages, and that puts a pressure on the social security system, right? So all these things that happened in the past have effects in our population, even after decades and decades, okay? And because you see this jump from 41 to 79 million, the baby boomers, even if they don't have a fertility as high as their parents, but now they are a bigger group, 79 million, even if they have 1 or 1.5 children on average, the next generations will be bigger than the previous ones, because now the population overall is bigger, is larger, right? And this is also over time, the number of, the size of the US population from 1870 to the 2000s, and then just dividing them by these specific groups. And again, the same trend of this jump from the lucky few to the baby boomers, right? And even if those guys here don't have as high of a fertility as their parents, still you have bigger generations following in the next decades. Cool? Now, the Lexis diagram. The Lexis diagram is something that's not in the textbook. And there are questions about the Lexis diagram in quizzes and exams. So it's important to understand the Lexis diagram. Why do I put the Lexis diagram here? The Lexis diagram is a simple graph, really simple graph of time by age, in which we can summarize how we can analyze trends in population size, and also both over time and by age groups, right? We can try, depending on the data that we have available, we do specific kinds of analysis. And the Lexis diagram summarizes it very well, right? So the Lexis diagram is something that all demographers know what it is, and it's important for you guys to understand it. So the Lexis diagram is a graph that provides the relationship between the chronological time in the horizontal axis and age in the vertical axis. If you count each person since the time that the person was born and getting old in your society, you can create a lifeline on the axis diagram, on the Lexis diagram. You pretty much, that person will start in the horizontal axis on T, on the year that that person was born, and then it's gonna increase into the next years for every additional year by 1 age, right? So for each person, you have one lifeline. This person here was born around 1940s, a little after. And then it got older, 1 year of age for every additional year, and then died here, right before 1950. This person here was born, let's say, around 1925, and for every additional year of time, the person got 1 year older, and that person, in this specific example, died around, let's say, 1976, right? Around here. So if we have a population of 300 million people, I could do a Lexis diagram with these lifelines for each individual. And each individual starts in the horizontal axis here in the year that the person was born, and it goes up and it disappears on the year that it died. In this specific case, that's just a hypothetical example done in this other textbook that I cited that you can look in the references too. And this textbook is more related to methods in demography, and it's available for free here at Texas A&M. You can download the entire book. It's Essential Demographic Methods. That's the name of the book. So the Lexis diagram pretty much shows us that when people were born, how they're getting older and when they die. When they're born, getting older until they die, okay? So each person has a lifeline on a Lexis diagram. It's starting at T0, where TB is the person's birth date and 0 is the person's age. The line goes up to the right with a slope equal to one additional year of time. The person gets 1 year older. People age 1 year in 1 calendar year. And the lifeline goes up until time and age of the person's death, okay? So we know here that this person died around 1970 and was around like 70 years old, okay? So the Lexis diagram allows us to show in a graphical format how the population, when the population is being born and by which age they are dying and when they are dying as well. And you see here that you have more people being born here in this example than over here, nobody being born in those specific years. So you can see an increase in fertility when you have more lifelines around a specific subportion of the graph. So we can explore a little bit the Lexis diagram. How do we find the population size of a specific country or specific population using the Lexis diagram for a specific year? We draw a vertical line upward from the time point and count how many lifelines cross that vertical line. So in this example here, what was the population of this society in 1980? How many people were alive in 1980 in this example? 3. We draw a vertical line here. 3 people. I tried to find one that was not so difficult to see, visually speaking, right? This example in 2000, 2 people alive. So that's the population of that specific society in that specific example, right? Using the Lexis diagram. To find how many people survive to the same age, we draw a horizontal line across the height corresponding to the age that we are analyzing. And then we count how many lifelines cross the horizontal line. Because let's say, for example, we want to know throughout this last decades, people around 40 years of age, that's an age in which they already have good education, and then you're supposed to have some experience already in the labor market. I want to know how they improved or had some challenges throughout their lives. If we're looking for different generations, people that were born in different time points, but they all reach 40 years of age. How many people from this population we have to analyze here in this case? How many people reach at least 40 years of age? We have 3, 6, 8 people, right? That reach at least 40 years of age in this time interval, okay? So the Lexis diagram allows us to see the size of the population in a specific year and allow us to also count how many people reach a specific age throughout that time period that we have the data for. And let's say that we have immigrants. Immigrants start in that population above age 0. They can start that population above age 0. How do they enter the Lexis diagram? They enter at the age and time of immigration. So someone who entered the US, for example, let's say that this is the US, around the age 20. So the person enters in age 20, so the person will start here and then we start getting older in the next year. And then the person will get out. Also the time of death. Oh, but if you're taking into account immigration, are you also taking into account immigration? So the person can disappear from here, both because of death or because moving out to another country, right? If migration is taken into account, if migration is being taken into account, then we can have people starting above age 0 from here in this example that I did, and people can get out not only because of death, but because of immigration as well, okay? That depends on the data that you have available. And and how do we see cohorts in the Lexis diagram? How do we usually use the Lexis diagram in demographic analysis? We can see group of people sharing the same birth date. We can see how many people were born around the same years in a specific time interval, right? So that's people born around the same time point. That's a birth cohort. We can see groups of individuals follow simultaneously through time and age, and then we can follow them through time and age to see if they experience the same socioeconomic challenges in terms of getting jobs, in terms of getting education and so on, compared to other groups. And whenever you are doing analysis in a cohort analysis in the Lexis diagram, you are looking at the lifelines diagonally. You are looking how these people growing up together experience the same aspects of the society. In a cohort, and look at the Lexis diagram, age and time goes up together. They go up together. A cohort share experiences, and we try to understand the overall experience of that group of people. And we can summarize even more the Lexis diagram this way here. If we have data for one time point, such as we usually do, right? We have the census for example, 1950, 60, 70, 80, 1990, 2000, 2010, until 2020 right now. Let's say that we have for 1980. We have the census for 1980, and we want to understand the age composition of that population and other aspects of that population. I'm doing an analysis of period, right? It's a period analysis. But let's say I have more refined data. And I can follow people over time because I have data that came from several decades ago. And then I know people that were born around 1910, and I can follow them over time. That's a cohort analysis. In the cohort analysis, there is a specificity here. Let's say that I get people that were born in 1910. I interview them or interview their families in 1910. And then I follow all these people, all these same people throughout their lives. And I interview them, let's say, every 5 years. Same people. It doesn't matter where they are. I go after them. In that case, I can actually do a longitudinal analysis, right? I'm following the same people over time. I have panel data, right? I can follow people over time. That kind of data is really, really expensive to have. Following the same people over time and get information from them, people move out. They change their contact information, phone number, address, or they refuse, right? They can answer my questionnaire 3 times in 3 waves, and then afterwards, no, I don't want to do it anymore. So there is attrition when I cannot reach all people that I had in my first wave, right? So longitudinal data, true longitudinal data is expensive to get. Even let's say I have all this population that was born in a specific city in 1910, I don't have money to follow them through time, I will get just a sample. And this sample here, only this small group, if I follow them, they are representative to my full population. But even for that small group, it's hard to follow them over time. We can still have the same attrition problems. So what we can do, one thing that I can do, I can go in 1910, I get a sample of this population, interview them. And then I go in 1920, and from the population that was born in 1910, I interview another subgroup of them. So these people here are being interviewed, of course, their families, when they were just born, 0 years old. From that same group of people, I get another sample. Now they are 10 years old. 10 years later, 1930, I get those people there, they're 20 years old. So I have a bunch of different subgroups of that same cohort being interviewed throughout the years. But all these subgroups that I interviewed in 1910, in 1920, in 1930, they are representative to everybody. I have men and women. I have people that live in different portions of the country or this area. I have people that are from families with different socioeconomic status and so on. I have variation. They are representative to the whole group. In that case, I know that these people that I interview in 1910 are different than the 1920s, different than 1930, but they are representative to the group of people born in 1910. Then I can still do a cohort analysis. It's not a pure longitudinal analysis. I don't have a panel data following the same people over time, but I have subgroups of this population that I was able to conduct interviews, implement a questionnaire with them. So that's a cohort analysis. And let's say, like that example that I gave before, in this case here, I want to understand the challenges or the life, how life changed for people that are around 35 years old through time. I want to know from people of different generations how their situations were when they were 35. So I'm doing an analysis for the age group, people around 35 years of age, over time, okay? This specific analysis of period is also called cross-sectional, because just think here, you have several different cohorts, right? You have another cohort here, people born here, born in 1940, 1950, 1960, and so on. You have all these sections, right? All these sections, all these subgroups, all these cohorts, generations of people that are captured here in the Lexis diagram. Period data, I'm collecting information from a series of different sections, different cohorts. So period data can also be called cross-sectional. When you say, someone said, oh, you just have cross-sectional data. Yeah, cross-sectional data is data from a specific time point that I'm collecting information for people that were born in all these different years. The people here in 1980 that were born in 1960, 50, 40, 30, 20, and so on. And even the cohort analysis, if you don't have longitudinal data, you have to say, oh, I used cross-sectional data. In other words, samples from different years, and then I put them together. What matters to me is what? Here, for example, 1920. I go here, I have the data for everybody in 1920, but I just want to get information for these people. I go there in the 1930 census, and I just get information for these people around 20 years of age. 1940, I just get information for these people here. 1960, 1980, and then in 2000. In that case, I still have cross-sectional data, period data, but I'm building my cohorts using this period data, even without longitudinal analysis. So the Lexis diagram is really interesting because let us understand the nature of the data that we have and what are the limitations and what are the advantages that we have depending on the data. Longitudinal analysis data is really, really good because then you control for the individual aspects of people and then you can follow them through time. But it's much more expensive, much harder to collect, right? So that's why we usually get cross-sectional data and we build our own cohorts doing this exercise that I just explained. Cool? When we calculate a period measure, there's something different than what I just said now. When we calculate a period measure, we pretend that the age-specific rates we see today for different age groups continue unchanged into the future. We kind of created an imaginary cohort whose life experiences pieced together from the experience of different people found at different ages in one period of time. What does it mean? Too complicated to understand this slide. When I have period data, let's say in this example here, I have data for 2000. I get the 2000 census and I calculate life expectancy at birth, the average number of years that I expect people to live. I calculate total fertility rate, the average number of children that women are having. And what these numbers mean? Life expectancy at birth. I'm saying that based on data from 2000, in 2000 here, I know how many people died at age 5 before reaching age 5, before reach age 0, 5, 10, 15, 20, and so on. So I have the mortality rates for each age group, or the age-specific mortality rates. Let's say now that I get this hypothetical group of people, this imaginary group of people that I mentioned in the previous slide, and I expose them to these mortality rates that I measure using only 2000 data. What I'm saying is that, let's say I get a group of people and exposed to this chance of dying at age 4, this chance of dying at age 5, this chance of dying at age 10, and so on. And I get a number of 78. Life expectancy equals to 78. I'm saying that if I get a group of people and expose them to these mortality rates throughout their lives, they will live on average 78 years. Well, so what I'm doing is getting period data and imagining this cohort here. I'm saying, let's take all these rates that we estimate in 2000 and get a group of people that will experience it throughout their whole life. They will live on average 78 years. Why is that? Because people now who are 10 years old, they're exposed to the chances of dying for people who are 10 years old now, right? That's the data collected here. When these people reach 20 years of age, is their mortality going to be measured here? No. Their mortality is going to be measured here in 2010. In 2010, the people who are 10 years old are going to be 20 years old. And then we're going to have their mortality measured here. And then in 2020, they're going to be 30 years old. So to actually know the mortality experience of these people who are 10 years old in 2000, I have to follow them over time. Too expensive. Too expensive. How do we simplify that? We simplify that by saying, let's get the data for everybody now in 2000. Let's create a measure that's saying, let's expose all these people to these chances of dying. How many years on average they will live? Total fertility rate, which was the other example. When we say that women have, on average, 2.1 children in a specific country in a specific year, what are we getting? For women between 15 and 49 years of age, the age range that we use for fertility, between 15 and 49 years of age, what's the fertility rate for women in each subgroup within this age range of 15 to 49. And then now let's expose this hypothetical group of women to these chances of having children. How many children they would have on average? 2.1 in my example, right? A woman who is 15 years old now, let's say in 2020, when she is 20 years old, she's going to have a chance of having children that can be measured only in 2025. So I don't have that data. So what we do, we use a period measure, this vertical bar here, this vertical column, and use it to create this hypothetical cohort, right? We call this imaginary cohort the synthetic cohort. We are piecing pieces together. The age-specific cohort rates of the synthetic cohort are the age-specific period rates of that specific year in that population. And this concept of synthetic cohort is central in demography because we usually get period data, apply that period data to this imaginary cohort to understand the level of mortality, fertility, migration of that population in that time point by implementing it, by doing this exercise of implementing it to this imaginary cohort. And then the last part of, I will just go through really quick here, but I will go back to this on Thursday, is to differentiate between ratios, rates, and probabilities. Ratios is when we are comparing the sizes of two specific subgroups of my population, right? So let's say that from this population, I count how many women and how many men are there. And then I divide men by women. That's the sex ratio. Why it's called sex ratio and not sex rate? Because the denominator is a different subgroup of the population than my numerator. The denominator in that specific time point, that specific year, does not have a chance of going to the numerator. In that case, I'm asking the question about sex, about being male or female. I'm being really simplifying here, just male and female, and each person self-identifies in one of those for that specific year. Two groups. Dependency ratio. Dependency ratio, I count in my population how many children, people in labor ages, and older people are there. Then I get the children and the older people, put in the numerator. In the denominator, put people in labor ages. Why is dependency ratio not dependency rate? Because these people in labor ages are a different group than children and older people, right? That specific year, they are in that specific age group. Rates that describe the number of occurrences of an event for a given number of individuals who had the chance to experience that event per unit of time. If I get my population here, I count everybody here, put in my denominator. And then from that same population, I count how many children were born, or how many, let's say, I count how many women are in that population and how many of those women had children in that specific year. Why is that called a fertility rate and not a fertility ratio? Because the woman in the denominator have the chance of experience the event being measured in the numerator. Mortality. Let's get everybody who is between 20 and 24 years of age in a population, put in the denominator. How many of those people between 20 and 24 died in that specific year? Put in the numerator. Why that is called a mortality rate and not a mortality ratio? because these people that were counted at the beginning here, my mortality in this mortality indicator, these are people between 20 and 24, and they have the chance of experience the event that's being measured in the numerator. They are alive now, so they have the chance of dying this year, right? And probability, the difference between probability and rate is that probability I get the numerator, the denominator is the population at the beginning of the year. The rate, the denominator is the population in the middle of the year. And I will discuss these three things, ratios, rates, and probabilities more in depth on Thursday. It's 12:25 now. Thank you very much, and I see you this coming Thursday.